All right, welcome to 1.6. We're going to talk about trend lines, and we're also going to venture into 1.7, which is line of best fit. So starting with 1.6, we're going to be able to write a linear equation that models data, real-world data. We're going to create and analyze trend lines and use that data to make predictions. So a trend line is just a line that passes through the data modeling the situation. So how we are going to go about writing an equation of a trend line, we're going to take the scatter plots that we worked on last section. We're going to graph that scatter plot. We're going to sketch a trend line. So we're just going to sketch a line that goes through or is in the middle of most of our data that would model that data well. Choose 2 points on that trend line. Then we're going to use those 2 points to find the slope of the line, and then write that equation in point-slope form to simplify to slope-intercept form. So let's look at some examples. All right, so this table shows the percent of US households with internet access. Step 1 says make a scatter plot. Let X be the number of years since 1995. So that is important because we're not graphing 1997. We're going to end up graphing 2 because it's 2 years since 1995, 5, 6, 8, and 12 as our X values, and then our Y values are the percent. So our independent variable on the X-axis is the years since 1995. And we need to go to 12. So we're just going to go about every 5 there, like that. And then on the y-axis, or our dependent variable, we're going to write the percent. And so our percent ranges from about 18 to 62. So again, we're going to start at, let's say, 15, and we'll go up maybe by 5. All the way up to 65. Okay, so now that I have my axes labeled, I can plot these points. So I'm going to graph 2, 18, which will be about there. I'm going to graph 5, 41.5, about there. 6, 50.4. And again, these might not be perfectly exact, and that's okay. We're doing the best we can. 8, 54.7. And then 12, 61.2. Okay, so there's my scatter plot. Step 2 says, describe what the scatter plot reveals about relationships between years and the percentage of households with internet access. So this is showing a positive correlation. So what that means is that as time goes on, the percent of households with internet access increases. Okay, again, we do see that positive correlation. All right, so in order to do step 3 of sketching a trend line, I'm gonna quick graph this again. So I'm labeling my axes. So this is 15, 25, 35, 45, 55, 65. Okay, and remember the y-axis is years, the x-axis is years and the y-axis is percent. And I graphed 2, 18. If you guys have already done this, you're not going to have to do it a second time. I just ran out of space on my slide, so we're going to do it again real quick. 5, 41.5, 6, 50.4, 8, 54.7, and then 12 is 61.7, so that's somewhere over there. Okay, and when we go to graph or sketch a trend line, our goal is to find a line that goes through as many points as possible or evenly in between them. So we have 5 points on here. We're going to try and find something that goes kind of right through all of them. So let's sketch something like that. Right? So it hits close to one of them, but it really it's kind of in the middle of them all, right? There's 2 on one side, there's 3 on the other, so it's a pretty good line of best fit. Okay, and we're going to just find 2 points on this graph. And again, sometimes this is going to be easier to do than other times, so we're just going to do our best here. So I'm going to say that this is 0, 10, because that looks about right there. And then I'm going to say this is about 7, 50. So I just found 2 points that were easy to spot on this graph that I drew. Okay, and now we're going to write an equation for that line in slope-intercept form. So the first thing I have to do is find the slope. So I'm taking y2 minus y1, x2 minus x1. That gives me 40 over 7, which is 5.7. And lucky for me, the way that I did this, I already have my y-intercept. So my equation of my line is just going to be y equals 5.7x plus 10. Okay, so that is the equation of the trend line that I drew. And what does that actually tell us? So again, here is my equation, y equals 5.7x plus 10. What is that telling us? Well, the slope of 5.7 tells us that the percentage of internet access is increasing by 5.7% each year. Okay, and the y-intercept, that 10, tells me that 10% of households had internet access in 1995 when we started. Because that would be year 0. So at year 0, 10% of households had access. All right, and then last, we're going to use the equation of this trend line to predict the percent of households with internet access in 2027. So remember, for years, this is years since 1995. So to figure out what I'm going to plug in for X, I'm going to take 2027 and minus 1995, and that gives me 32. So that's the X value that I'm going to use. And then I'm going to take my equation that I came up with, 5.7x plus 10, and I'm going to plug that in for X. So I'm taking this 32, plugging it in right here. So I get y equals 5.7 times 32 plus 10, and I can just evaluate that in my calculator, and that's 192.4%. So according to the trend line that we drew, in 2027, 192% of households will have internet access. Okay, so we're going to continue on here in 1.7, and we're going to say, okay, we drew a trend line based on what we predicted and how we drew our scatter plot. But in 1.7, we're going to actually use a graphing calculator to find the line of best fit. And this is just going to be a little bit more exact than if we're making a guess on our own. So the line of best fit is the trend line that gives the most accurate model. And we're going to do that using our calculator. And the way that we're going to do that is called this linear regression. So to do that on your calculator, and this is also in your note packet for those of you that are following along, you're going to press stat. It is directly to the left of your arrow buttons, the circular arrow buttons in the second row. So you're going to press stat, and then you're going to select option 1, which says edit, and you're going to enter your data into L1 and L2. So L1 is going to be your X values or your independent variable. And then L2 is going to be your Y or your dependent. And to do this, you just type in your number and then hit enter, and it will scroll down to the next one. So you do that for all of your data. Once you have that done, you're going to press stat again, same button, directly to the left of the arrows. And then this time you're going to scroll over until calc is highlighted at the top. You're going to scroll down to select option 4, which is that linear regression that we talked about. And you're going to select that option. When you do that, it's going to pull up a new screen, and you want to make sure that it says XList L1 and YList L2. Why? Because that's what we put there. We put our X values as L1, we put our Y values as L2. And you're going to scroll down to the bottom, hit so calculate is highlighted, and hit enter. This is a screenshot of what it looks like when you're in the stat function. I will attach a separate video so that you can watch the process of this as well. Okay, so let's say that we did all that. We entered in our data. We're using the same data that we did in the previous example. So again, if I was entering this in my calculator, I would be putting in 2, 5, 6, 8, 12 as my X values, because these are years since 1995. And as my Y values, I'm putting in 18.0, 41.5, 50.4, 54.7, 61.7. I'm going to perform my linear regression, and the equation that it's going to give you is y equals 4.17x plus 17.72. So we weren't totally far off, but this line will be more accurate than what we predicted in the beginning of 1.6. Okay? And then the last step is, again, we're going to make a prediction using this trend line. And this is going to be a little bit more accurate. So it says, based on the equation of the line of best fit, which again is this equation right here, what year would you expect 80% of the household to have internet access? Okay, 80%, right? Is that our X? No, that's our Y. So we can't do it exactly like we did the other one. We're plugging that in as our Y value. So my equation is that Y equals 4.17x plus 1772. But now I'm going to put 80% as my Y value. And I'm going to just solve this like I would any other linear equation. So start by subtracting 17.72. And you get 62.28, and that equals 4.17x. Divide both sides by that 4.17, and you should get 14.94 years. So from 1995, that would put us in year 2009. We're almost to 2010, but not quite. Okay, so that is trend lines and linear regression.